Today we'll be talking about how to factor and solve polynomial equations. Very similar to what we did with quadratics. The only difference now would be the polynomials are going to have a higher degree. They'll be a little bit more difficult to factor, but we will have some shortcuts that I will show you that will make your life easier. So by the end you should be able to factor the polynomials and understand how to solve. So when we factor, please, please, please don't forget our very first step is to factor out the common monomial. Remember that we have issues with this. We always forget to factor out the common monomial first. Then we use the x if we can. If not, we have these two shortcuts that you have to memorize. You have to memorize. There is no other way for me to help you remember it but to memorize it. The first one is the sum, or the addition, of two cubes. These must be perfect cubes. And then we have the difference of two cubes. Now notice that the signs, everything is the same in the factored portion of the difference and the sum of two cubes. The only difference would be the signs in between. This one is plus minus plus. This one is minus plus plus. And I just remembered because if we're talking about the sum, it starts with the plus. And then we get plus minus plus. If we're talking about the difference, then it starts with the difference. And then we have difference plus plus. I will show you how they work later. However, if you do not have them memorized, there is no way you can remember how to use it. So let's begin with something that we know. So if we look at x cubed plus 2x squared minus 15x, remember, very first step, do not forget it, is to factor out the common monomial. If I look at x cubed, 2x squared, and 15x, the only thing that all three of them have in common as far as factors go is the letter x, or the variable x. There's no number in front of the x cubed. 2 and 15 both don't go into the same number, or they both don't have a number that goes into them. So the only thing we can factor out of all three is an x. If I take out an x, I'm going to be left with two x's at the beginning, and then one x in the middle, and then negative 15. And now that I've factored out that common monomial, I can factor this out using my x. So remember, a times c goes on top, and then b goes on the bottom. So my two numbers are going to be positive 5 and negative 3. Don't forget to divide by the a. In this case, it's 1. So you end up with x and x plus 5 and x minus 3. We go back to the beginning, which asks us just to factor. So all we need to do is stop there. Now let's look at this problem. We only have two terms, so this is a binomial, but this is a sum of two cubes because x cubed is a perfect cube and 64 is also a perfect cube. So now we have to remember, okay, it went plus and then minus plus. And then we have to fill in the rest. So we take the cube roots of each one of these two terms. X cubed, the cube root of that is x. And 64, the cube root of that is 4. So those two numbers go there. And then we square each one of those numbers. The x part goes at the beginning, and then the 4 squared goes at the end. And then in between, we take both of these numbers and multiply them together and put that in between right there. Now we can't factor this. There is no two numbers that multiply together to get 16 and add together to get negative 4. So we just leave it like this. So remember, I cannot stress enough, you you must memorize those formulas. Now let's try this one. Now we do have the sum, and I'm assuming it must be of two cubes because why else would they have given this to me? However, if we look at them, 16 is not a perfect cube, and 686 also not a perfect cube. But remember, we have to go back to step 1, which is to factor out the greatest common monomial. And if we look at these, I could definitely factor something out of both. So 16 and 686 are both at least divisible by 2. So we'll start with a 2. And then I have b to the 5th and b squared. So that means I can take out at least 2 b's from each. Now with the numbers I divide. So 16 divided by 2 is 8. And then with the b's, I just take out 2 b's from each one. So with the first one, I'll still be left with b cubed. Now with the second one, 686, that ends up being 343. And if I take out 2b's, I don't have any b's left over. And these are definitely cubes. The cube root of, sorry, let's write down the formula first. We're sort of talking about the sum. So sum comes first, and then minus plus, plus minus plus. So remember, the cube root of this goes here, and the cube root of this one goes here. So the cube root of 8b cubed is 2b, because b times itself 3 times gives us b cubed, and 2 times itself 3 times gives us 8. And now 343, the cube root of that, maybe not so obvious, but that's 7. Now remember that I square this and put that here, so that's 4b squared. And then I square that and put it at the end, so that gives us 49. And then I multiply the two together and put that in between, so that gives us 14b. And remember, after that, there's no possible way I can factor it any further, so this is my completely factored polynomial. Now, another factoring is what we call grouping, and I will show you that on this slide. Some teachers like to teach this during quadratics. Some teachers wait until the 4-term polynomials. But in order for grouping to work, it has to have 4 terms. 1, 2, 3, 4. So this one has 4 terms, so we can factor by grouping. And what we want to do is we want to group in 2s, 2 terms at a time. Now we look at each individual group and factor out the greatest common monomial. So if we look at the first group, I've got no number in front of the x cubed except for a 1, so I can factor out a 1. And then I have x cubed and x squared, so out of the first one I can factor out a x squared. When I factor out x squared, I'm going to be left with x minus 3. Now if we look at the second one, our goal is to get some sort of factor that looks like this. Now if we look here, we have a subtraction sign here, so 99% of the time we want to factor out a negative something because we want that first term to be a positive. So I can factor out a negative 16. And when I do that, I'm left with positive x and then negative 3. And look, these two factors are exactly the same. That is our goal, is to get these two factors exactly the same, because what we do is we put that here, and then we take the leftover part, and that's a factor over here. And the last thing we have to do is look at both of those and ask ourselves, can we factor it? We can. We can factor this part. X squared minus 16 is what we call the difference of two squares. Now since it's the difference of two squares, what I can do is I end up with plus or minus, and I take the square root. I take the square root of x squared and put that here. I take the square root of 16 and put that here, and now I've just factored it completely. And if you aren't comfortable with that, again, remember we can go back to the negative 16 and 0 like we did before in the x and factor it that way. Either way is completely fine. So you try the next. Now maybe it's not so obvious to see in this one, but this one is the difference of two squares. Definitely not cubes because I have this x to the 4th here and I can't take the cube root of x to the 4th. So it's a difference of two squares. So remember, one's going to be plus and one's going to be minus. I take the square root of this one, which is 4x squared, and put that here. Then I take the square root of this one, which is 9, and put that here. Now, I don't have the sum of two squares, so that one has to stay the same. But this one, again, is the difference of two squares, because I can take the square root of 4x, and I could take the square root of 9. And remember that one is plus and one is minus. And we end up with this. So let's try this one. If I look at all three terms, each term is divisible by 2. And each term has a p squared in it, so I can take out a p squared. If I take out a p squared out of the first term, I end up with p to the 6th. Remember that we would subtract the x when we're dividing. Then the second one, 10 divided by 2 is 5. And then if I take out two p's, I'm going to be left with 3. And then 12 divided by 2 is 6, and if I take out 2 p's, I have no more. And then I can factor it. 6 and 5 gives us 3 and 2. So I end up with 2p squared, but this time, because I have p to the 6th and p to the 3rd, that first term is going to be p to the 3rd plus 3, and p to the 3rd plus 2. Remember before we had something like this. It would be p plus 3 and p plus 2. And we get what that exponent should be by what that exponent is. Okay, so we end up with this. So why don't you try this one, pause the video and try this one yourself. Okay, obviously we have 4 terms here, so we want to factor by grouping. If I look at the first parentheses, I can take out an x squared and I'll be left with x plus 7. If I look at the second parentheses, because I have the subtraction, I'm going to factor out a negative 9 and I get x plus 7, and lo and behold, these are exactly alike, so we leave that over here. And then remember that we take whatever is left over, and that's the other factor over here. But, uh-oh, we've got a difference of 2 squares. So we get x plus 3 and x minus 3, and then we get x plus 7. Just like that. So why don't you try this one by yourself? So we have a difference on this one. And it's obviously not cubed because I have g to the 4th, so it must be the difference of 2 squares, so plus minus. I take the square root of the first one, which is 4g squared. And then I take the square root of the second one, which is 25. And then I double check it again. This one is fine. I can't do anything with this, but oh, look at this one. That is, again, the difference of 2 squares. So I get 4g squared plus 25. And then a plus minus again, right? The square root of this one is 2g. The square root of the last one is 5. And now I cannot factor it any further. So let's try this one. 4, 20, and 24, all divisible by 4. T to the 6th, t to the 4th, and t squared means I can take out at least 2 from each. So I'm going to be left with t to the 4th plus 5t squared plus 6. Which looks an awful lot like the p problem we had before. So now I factor this part. The two numbers that multiply together to get 6 and add together to get 5 is 3 and 2. I don't have an a to divide by, so I leave it like this. So I get 4t squared. Now comes the tricky part. I'm going to have t squared. Remember that this tells us sort of what that exponent should be at the top. And then we end up with plus 3 and plus 2. And both of these are both sums. We only have the difference of 2 squares or the difference of 2 cubes, which is not what I have there. Okay, now let's talk about solving. So remember before that when we solve by factoring, first we factor and then we use the zero product property. The zero product property. So if I look at this one, first step in factoring is to factor out the greatest common monomial, which is x squared. When I factor that out, I'm going to be left with x minus 5. And then we use a zero product property and set both of those equal to 0. If I set the first one equal to 0, I just get 0. If I set the second one equal to 0, I add 5 to both sides and I end up with 5. So I get 0 and 5. Computer.